In this video, we're going to introduce functions. So functions. So in every mathematical course or any course in general, there is always some particular concept that we first need to cover before we can confidently start the course. So in our case, differential calculus, one of its basic notions that we really need to fully grasp are functions. So since we will be dealing and encountering this until the last topic in calculus, so it is really best that we build up and strengthen our foundations to this concept. So before we start, let us begin by expressing a function with symbols. So let's say we have a rectangle here, and this is our function. So this is our function. And an arrow pointing towards the box is our input, and away from our box is our output. So as you can see with this diagram, we can see that the function is just a special relationship between an input and an output. So a function is just a relationship between these two. You process the input using a function and you will get your desired output. So let's have a simple example. Let's represent a function with a fruit juicer. So juicer. So let's say a function is a fruit juicer. So if we have an apple for our input, let's say apple, we have a yellow apple. If we have an apple for our input and we subject it to the juicer, it is obvious that we would get an apple juice. So our output is the apple juice. And if you try other fruits, you would get a different output for every fruit. So this is only one example of a function. However, functions can be represented in various ways, and one of which is through symbols, which we already discussed using this diagram. And there are other ways such as, so we have through symbols, and we have through equations or in equation form. So we have equations. We can also represent it with tables or in tabular form. So it can be in tables or in graphs or in graphical form, graphs, or even with words, or we can say phrases. Phrases. So we have symbols, equations, tables, graphs, or phrases. So these are just few of the examples that we can represent a function with. This is through symbols. So we already have with symbols. So what about equations? So let's say we have an equation of, let's say y is equal to 2x plus 1. So in this case, this part is our function. In this x is our input, and our y is our output. So how do we do that? So let's say we have done that apple. We have input our apple to the juicer, and we have an apple juice. In this case, we just replace x with any desired value. So in this case, let's say 5. So if x is 5, let's just replace x with 5. So in this case, 2. Instead of writing x, we write 5. So let's have a different color for our input. So 5 plus 1. So 2 times 5 is 10, plus 1, we get 11. So our input now is 11. So if we have an input of 5, we have an output of 11. So your function only tells or give instructions to what you can do with your input in order to get your desired output. So we now have through symbols, we already have through equations. Now, before we could proceed with this too, let's first start with phrases. So in phrases, let's have a simple example. So for example, there are two oranges. There are two oranges for every apple. Okay, so this is with phrases. Now, let's say we have, there are two oranges for every apple. So that means that the number of oranges is twice the number of the apple. With this, we can formulate an equation just using this statement. So let's say the number of oranges, so the number of oranges is just equal to the twice the number of your apples. So apples. So with this, we can now, this is just an equation. This is now represented in an equation form. To further simplify this and represent it in this notation, instead of oranges, we can represent it with a variable y and our apple with x. So instead of writing this, we can now write it as y is equal to 2x. So as you can see, from phrases, we have converted into an equation form. Now, we now have 3, and the only left here is this 2. So let's have tables. So in this case, if we have this equation, let's try to create a table out of this. So let's have a table. So if our input is our apple, so let's say we have an apple for our input. This is the variable x, the oranges for our output. So orange. So this is the variable y. So if we have one apple, if we replace this with 1 times 2, we would get 2 oranges. So we would have 2 oranges. If we have 2 apples times 2, we have 4. If we have 3, we have 6 oranges. If we have 4, we have 8 oranges. So with this, as you can see, this function from phrases, we have converted it into an equation form. And now we also have represented the same function through tabular form. Okay, let's go back to our list. So we now have through tables. So what about in graphs? What about graphs? So in this case, let's use this example again. So if you could recall in analytic geometry, we have a Cartesian plane. So if we have a Cartesian plane here, let's say, okay, this is the x-axis. The horizontal axis is usually represented by the x-axis and our vertical axis as our y-axis. So with this, we can now create an ordered pair. So let's say if our x is 1, our y is 2. So with this, we can now create an ordered pair of 1, 2. The same with this, we have 2, 4, and so on. So 3, 6, we have 4, 8, and we can continue on and on until we desire. So with this, we can just plot these points through this Cartesian plane. So if we have 1, so 1 for our x, and we have 2 for y. So this is our first point. This is 1, 2. And for our second point, 2, 4, we have 2 for the x-axis and 4 for the y-axis. So in this case, it's here. So this is our second point, which is 2, 4. Our third point, 3 and 6. So this is our third point, and our fourth point would probably be here. And if we plot this, it would roughly look like this. Let's just fix this. Okay. So now, with this, from phrases, we had converted it into an equation form, through tabular form, and now through graphs. So we now also have graphs.